Okay, here's a little video on implicit differentiation. So taking a look at homework 7, problem 1. Got that set up over here on the OneNote. So once again, the idea is to take the derivative of both sides of this equation, because we don't want to try to get the y by itself, and then just take the derivative explicitly. So if we take the derivative of both sides, now we notice this first term is a product rule because we have something times something. The 2x is my first, is like my u, if you will, and the y cubed is the v. So the derivative of 2x would be 2 dx, which of course is, I'm going to go ahead and write that, dx, which is just 1, times y cubed, plus, then we have 2x times the derivative of y cubed, which would be 3y squared dy dx, plus, now take the derivative of 5xy. The derivative of 5x is 5 dx times y plus 5x times the derivative of y, which is dy dx. And finally, derivative of 28 is 0. Okay, so now you know, you go through and look at all this, and the dx is just 1. So this just becomes 2y cubed. The 2x, 3y squared dy dx. Now dy dx is not 1, so it stays there. And I can combine these into 6xy squared dy dx. And dx is just 1, so this is just 5y. And then finally 5x dy dx, that's not 1, so I have to write it. Okay, now the whole purpose of this is to find, well, the question was to find the slope of the tangent line at this point, at 4, 1. So because I've taken the derivative already, I can just plug the 4 in for x and the 1 in for y, so I'm going to do that now. So that'd be 2 times 1 cubed plus 6 times 4 times 1 squared dy dx plus 5 times 1 plus 5 times 4 dy dx equals 0. So then I have 2 plus 24 dy dx plus 5 plus 20 dy dx equals 0. A little bit. So the 2 and the 5 give me 7. Yeah, so that'd be 7 plus, and the 24 dy dx and the 20 dy dx, that would be 44 dy dx. That's equal to 0, which means dy dx would be equal to -7, and then divide by 44. Let's go back and just to make sure, we'll check it, plug it in. So that would be -7 divided by 44. Yay. So this is problem 2 of homework 7, and in this case they have an equation here, and they ask you to, they tell you that g of 4 is 4, and they ask you to find g prime of 4. Now this one looks a little bit weird because they've written it in function notation instead of the normal, the other one was written in with a y instead of gx, but remember g of x is just another way of writing y. G of x just reminds us that y is a function of x, or y depends on x. And so what So let's go over, I've written this stuff over here. So just to translate this, what they're telling you here, is that when x equals 4, y equals 4. That's what this information tells us, right? And they're asking you to find g prime of 4. That means another way to say that would be dy dx evaluated at x equals 4. Those two say the same thing. Okay, so after we've done that translation, this would probably sit better with some of you if I wrote this as y squared plus 15x is equal to x squared y plus 12. Same exact thing. Okay, so then this is an equation where it is written in explicit form. The x and y's are mixed in together. So I could take the derivative of both sides instead of trying to solve for y. So the derivative of this would be 2y dy dx, and this would be 15 dx dx. Derivative of this require the product rule, so that'd be 2x dx dx times y plus x squared times the derivative of y, which would be dy dx, and then the derivative of 12 is 0. Go in like we did before. Oh, and let's keep in mind our point is what? 4, 4, right? 4, 4. So go back over here. Can't change that. 2y dy dx. The dx dx is 1, so this is just 15. The dx dx is 1, so this is just 2xy. And this would be x squared dy dx. Now I can plug my 4 in. So this would be 2 times 4 dy dx plus 15. 2 times 4 times 4 plus 4 squared, which is 16, dy dx. Now I just got to get the dy dx together. So this is going to be 8 dy dx, and I'll move the 16 over there, so it'll be minus 16 dy dx. Move the 15 over here, that'd be negative 15 plus, and that would be 16 times 2 is 32. Okay, so when we combine these, we get negative 8 dy dx, and negative 15 plus 32 is 17. And so finally we get dy dx is equal to negative 17 over 8. And when we take a look at web work, I've actually already did this one a while ago, so you can see the answer is in there. Yep, it's correct. Okay, so there's a couple of implicit differentiation ones. We could probably do this one. We'll do one more. Okay, so here we go. Problem number 3. It says find the slope of the tangent line to the curve. There's the curve, and there's the point where we want to find the point of the tangent line. So I've already written that over here. So right away we're going to take the derivative of both sides. So the derivative of 6 sine x, that would be 6 cosine x dx dx. Again, you don't have to write this dx dx. I'm just doing it to make it clear because some people have been uncertain about where the dy dx comes in when we're doing this. So I'm just showing you that there's always a something dx, and sometimes it's 1, sometimes it's dy dx. Okay. So here you got 2 cosine y. That would be that would be a negative 2 sine y dy dx minus, now this is going to be a product rule, so that would be, the first would be negative 6 cosine x dx dx cosine y minus, because that negative 6 goes along here, and that would be a sine x, and then the derivative of cosine y would be a negative, so I'd make that positive, sine y dy dx, and then the derivative of x is just dx dx, and the derivative of 4 pi, of course, is 0, because that's a constant. Okay, go through and clean it up. So I got 6 cosine x dx dx is 1, so that drops out. This would be negative, so I can just make that a minus 2 sine y dy dx, because that's not 1, minus 6 cosine x dx dx is 1, so I'll just drop that out, cosine y, plus 6 sine x, oops, sine y dy dx, and dx dx is 1, so I put a 1, and I get 0. So then I can go through and plug in all the numbers. So this would be cosine of 4 pi. So cosine of 4 pi would be 1, so that'd be 6 minus, and this is 2 times sine of y, that'd be sine of 7 pi over 2, which would be, let's see, sine is 0 at all the pi over 2, so that would just be 0. So that whole thing's going to disappear. And this is going to be 6 times cosine of 4 pi, which would be 1 again. And then cosine of 7 pi over 2, that's, whoops, I messed that up. Sine of 7 pi over 2 would be 1. There we go. Because if you think about sine, pi over 2 is right there, 3 pi over 2. 1 pi over 2, 2 pi over 2, 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. Ah, it'd be negative 1. Wow, that was close to being embarrassing. Okay. So then 6 cosine x, cosine of 4 pi, that'd be 1. And cosine of 7 pi over 2, that would be 0. That one was 0. And then 6 times sine of x, that's sine of 4 pi over 2, that's 0. And sine of y, that'd be negative 1, but it doesn't really matter. Dy dx, again, doesn't really matter because there's a 0 in there. Plus 1 equals 0. So then that's 0 and that's 0. So we're left with a 6 minus 2 dy dx plus 1 equals 0. So I have a negative 2 dy dx is equal to a negative 7. So dy dx is equal to 7 halves. Now, if I did all the trig right, this should be right. So I caught a little mistake. When I did negative 1 times negative 2, I got negative 2, which is of course wrong, so that should have been a positive, which would have made this positive, which would have made this negative. So let's see if that's correct now. So that should be a negative there. There we go.